Hello everyone, back into the 13th and final winter 2019-2020 update from GWV.com. So we started winter updates for winter of 2019-2020 on the first day of September. The very first day of September was the day we released update number 1. We've done 12 winter updates so far, as well as 2 seasonal model roundups. And this is it. We have come to the end of the winter updates now. Just got this 13th and final update to get through. And then that's it. We will be at the end of our updates. All that will be left to do will be a final season model roundup on Saturday. And then release a forecast on Sunday, the 1st of December. So we're really running the clock down now on the winter updates. We've got one more to do. But have we saved the best for last? Well, it's not for me to judge, but we've certainly got a very, very epic update for you to sign off with. We have got 110 tabs to go through and 3 sets of analogues, and more about that later on in the video. But this is going to be a trip. I'll put some breaks in as we go along so you'll be able to get up and stretch your legs and possibly come back to it later on. Yeah, this is going to be such an epic, and I'm very, very excited about this 13th update. It's the most ambitious winter update that we've ever attempted at GWV. So, get on that for you very shortly. Obviously, this is going to be a very long video, so you can't watch it all in one go. We place on winter updates page later on with a written summary going over everything that we discussed in the video. And I'll get that up for you around sort of 8 o'clock this evening, something like that. Big thank you to Analogues Guru James Acrill for his help with the analogues. Again, as always, big thank you to our Analogues Guru James Acrill. Thanks so much, James. And also big thanks to Richard Trott for supplying us with the winter updates gift that we've been using throughout this season of winter updates. Coming up later on, we're going to have a very busy day. So ECWF, Metro France and DWD long range model update will be with you probably around 3 o'clock this afternoon. There's going to be a live stream on YouTube talking about this winter update between 5 and 6 o'clock, and there'll be a Christmas update as well. Don't know how I'm going to get it all in, but I will get it all in for you. And it's all kicking off with this 13th winter update. Right, so I think that's pretty much everything we're going to take. Get yourself a cup of chair, a cup of tea, and some snacks. We're going to be here for a little while, so let's begin, shall we? The 13th winter update. We're going to start off with what's happening in the stratosphere over the North Pole. So currently, temperatures at 10 HPA in the stratosphere over North Pole are looking like this. Is from a JMA. So the grey line shows the trend for the time of year. It should be cooling down, getting colder in terms of the temperature in the stratosphere over Pole until it bottoms out around New Year and early January, when it starts to lift up through the first months of the following year. The black line shows where we've been. So a week or so ago, had a very cold temperature at 10 HPA. It has actually lifted up slightly, gone back closer to average. So a little bit of a warming has taken place at 10 HPA over past few days. So it's not a particularly dramatic warming, but it does get us back closer to average. In terms of the temperature at 30 HPA, which is a little bit lower down, closer to the troposphere, things have also warmed there a little bit as well. So the black line again shows that around a week or two ago it was very cold at 30 HPA. Actually now a little bit above average, a little bit above that grey line with the temperature at 30 HPA. So slight warming has occurred, but those temperatures of course are still very, very cold to say the least. Now this is from weatheriscool.com. This is showing the strength of the zonal winds. So as the temperature gets colder in the stratosphere at this time of the year, so the zonal winds get stronger, and this is all driving the polar vortex at its roots in the stratosphere. Now, not many days ago, a couple of weeks ago, we actually had a near record-breaking strong, or it actually was a date record strong zonal wind at 10 HPA. As we see from that blue line. There's lots of coloured lines on this, by the way. I haven't got time to go through all of them. If you want to know what they all represent, go back to update number 1. We go through every single line to explain what they're all showing. The black line is the trend, so that shows that as we're going into the end of the year, so the zonal winds are getting stronger and stronger as the polar vortex sort of powers up at its roots in the stratosphere. So the blue line is where we are this year, or where we are right now. Was very strong, record-breaking strong zonal winds at 10 HPA. When we looked at this a couple of weeks ago, where we are right now is around here, so we have deaccelerated the zonal winds quite strongly. We're back to average, and the GFS ensembles, these green lines just here, they're telling us that the zonal winds will continue to decelerate over the next couple of weeks. So this continues to drop. The strength of the zonal wind continues to drop and fall away. So in a couple of weeks' time, we're expecting the zonal winds to be around here. Not a reversal of zonal winds, not going down to this 0 line or below it, but definitely a continuing weakening of the zonal winds at 10 HPA and a real deceleration. Now we've got 3 pink and 1 blue line just here. They are from the CFS V2, and what we can see is that we have actually got 2 out of 4 members of the CFS suite, which is run 4 times a day. So 2 out of 4 are going for a reversal of zonal winds during December. That's the month of December just there. The other 2 are sort of strengthening the zonal winds, but the 1 pink and this blue line just here. Actually, the blue line is kind of flatlining at a relatively weak level, but it doesn't go for zonal winds. And the other pink line, that sort of strengthens things up. So 2 out of 4 appear to be going for a reversal of zonal winds through December, and the other 2 sort of one is quite weak, blue line is quite weak, the other pink line is strengthening the zonal winds through December. That's January as well, and that's February too, of course. But we know that the Mars have been flirting with this idea of a southern stratospheric warming through the early part of December. The GFS has backed off from that just a little bit over the past few days. So we shall see, but it definitely looks like 2 out of 4 of the CFS going for reversal of zonal winds. The other 2 are not going for a reversal of zonal winds. So it all remains to be seen how this is going to play out. But what we can definitively say is that from a very, very strong level with the zonal winds just here, we have seen a weakening, a rapid weakening of zonal winds, and we're going to get a further deceleration of zonal winds over the next couple of weeks. GFS ensembles are telling us that. Probably not getting to a reversal quite, but certainly a rapid, a massive weakening of zonal winds at 10 HPA. Which is interesting because we're now starting to see signs of the Arctic Oscillation strengthening. So this is the AO observed and forecast chart. The black line here shows where we've been with the Arctic Oscillation. Red lines at the end with GFS ensembles forecasting Arctic Oscillation go. Remember, this is just an index that's reflecting the atmospheric state, not driving anything. So in terms, it just tells us what the atmosphere is doing. So whilst we've had a cold temperature at 10 HPA, and a very, very strong zonal wind at 10 HPA. At the same time, though, and that's all in the stratospheric level, at the same time, the tropospheric level, where weather is taking place, the Arctic Oscillation has actually been trending negative. It's been in its negative phase, which tells us we've had a decoupling of the stratosphere, which is showing signals of a strong zonal wind and polar vortex, of the troposphere, which actually showing a blocking signal. When the Arctic Oscillation is negative like this, you've normally got blocking over the North Pole, and that would usually be associated with a warmish temperature at 10 HPA over the pole, and also a weakened zonal winds. It's quite interesting, quite perverse really, that as the zonal winds are going to be dropping away over the next couple of weeks, so the Arctic Oscillation is actually going to go from this negative phase, which tells us that there's high pressure over the pole at the moment, to a much more positive phase, seemingly. So we're going to continue to see a decoupling between the stratosphere and the troposphere, but this time it's going to be the case that the troposphere looks like it's going to power up the polar vortex and power up the westerlies at the same time as you would think that the stratosphere is beginning to weaken that off. So it's a very, very confusing picture what's happening at the moment in terms of the weather in the Arctic. This is the NAO observed and forecast, and again, same idea. Black line shows where we've been with the NAO, red lines at the end where GFS ensembles are forecasting the NEO to go. Now, the North Atlantic Oscillation has been in its negative phase really since the end of April, been in a prolonged negative phase, occasionally going positive, for example, here from mid-August to mid-September, and again more recently through the first half of November. But where we are right now with the NEO is neutral, and we're going to go negative again, seemingly through the last week of November into the first week of December. Some of these Onsettle members are trying to get the NEO back into positive territory late on, but it looks like, certainly for the next week to 10 days, the NEO is staying in its negative phase. Of course, this was the focus of the start of winter updates. Seems a very, very long time ago now, doesn't it? But right back at the beginning of these updates in September, we looked at the NEO, and we saw that when the NEO is very negative in the month of May, as it was in May this year, that is has quite a strong signal to be followed by a colder winter. And we still see this negative phase of the NEO continue. Remember, it's just an index that's reflecting the atmospheric state. So when the NEO is in its positive phase, you have low pressure on Iceland, high pressure through the Azores. You'll strengthen the westerlies across the Atlantic and into Europe. But when the NEO is negative, you'll tend to weaken the low pressure around Iceland and the high pressure through the Azores. Sometimes you will flip them. You'll get low pressure in the Azores and high pressure around Iceland. And that's the way you get the negative NEO. It's always the weather that drives the index. So a negative NEO is a signal for a colder type winter pattern. Right, this is the QBO from NASA. So this is showing every day's worth of QBO conditions going back to 2017, where we've got this sandy coloured area just here. That's where we've got the westerly phase of the QBO. The blue and green area is the easterly phase of the QBO. Remember, this is just, again, an index that's reflecting the atmospheric state. This time it's telling us the strength of the zonal westerlies. So when you're in a westerly QBO, the zonal westerlies are stronger, they're strengthened. When you're in an easterly QBO, the zonal westerlies are weakened. And sometimes an easterly QBO will be associated with a colder winter, but of course, not all the time. There are many examples where in an easterly QBO, but we have a mild winter. Anyway, where we are right now is just here. We've got the dates on the bottom, of course. Where we are right now is just here in the westerly phase of the QBO. But this westerly QBO is coming to an end quite quickly. Up here, we see this green and blue area descending down through the levels of the atmosphere. So we come over here, that's 10 HPA just there. So that's the level we were just talking about in terms of the stratosphere. So that's the top of the stratosphere, really, at 10 HPA, one of the top levels of the atmosphere, going down to 30 to 50 HPA. That's going into the tropospheric level, and then even further down onto the surface. So we see, again, this easterly QBO is descending down through the atmosphere, started at the top and is moving ever downwards. We've got to get those blue and green colours to 30 to 50 HPA, so kind of like this level just here. When we get this to 30 to 50 HPA, that will be when we can say we have moved from the westerly to the easterly phase of the QBO. Each individual bar reflects an individual day's QBO data. Now, if I zoom you in, I haven't done this before, I don't think, but if we zoom in and go over here, it does look as though we have now pretty much moved those green coloured lines down into the 30 30 HPA level just here. So we've almost now, it's interesting, it's happened for the final winter update, but we've almost now seen this QBO descend to the level of 30 HPA. It's just perhaps a little bit short of it, but it's very, very close. And I think this tells us that we're going to be moving into the ECQBO very, very quickly. Let me know what you think in the comments, but I think that's more or less now got down to this 30 HPA line just here. If I highlight that, there's the 30 HPA line just there. So I think we've almost now moved this ECQBO down to 30 HPA, which is the top of the troposphere if you like. And when that happens, we can say that we have moved from westerly to the easy phase of the QBO. May take another month, but I think it will be through this winter that we transition from west to east QBO. The easy QBO will then strengthen through the winter and into the spring. So the effects of the easy QBO is probably a time lag on the effects taking place. Could be a couple of months. So the easy QBO may not start to have all that much effect till later on in the winter, possibly a signal for a colder later winter perhaps. We did look at the QBO, of course, in an earlier winter update, so we looked at the data for west to east transitioning QBO winters. Right, looking at the oceans next. So this is how the oceans were looking last week. We did last week's winter update, last week's 12th winter update. 3 areas of interest. Got the ENSO region just here. Northern Pacific is up there. North Atlantic is over here. That's how things looked last week. This is how the things are looking this week. This is the very latest from the 21st of November. Let's deal with the ENSO region first of all. So we've established ENSO neutral on the warm side of ENSO neutral, at least to start the winter. That's what we're expecting. We discussed last week what the impacts of an ENSO neutral winter are likely to be. No change really in the ENSO region over the past week. So we're on the warm side of ENSO neutral. We're not expecting any change before the end of the year. Northern part of the Pacific Ocean remains warmer than average. That's something that we're going to have through this winter. That's not gone at all. It's not shifted or cooled. So it's going to remain warmer than average up there in the northeastern Pacific. That can be a colder signal for North America, as it can send the jet stream northwest to southeast and bring cold air down into the northeast part of America. And then as that jet stream comes across the Atlantic, it can blow up actually and bring cyclogenesis across the Atlantic into northern parts of Europe. So in the Pacific anyway, things are very, very stable. They haven't changed in the past week. What has happened though is that we're beginning to start seeing the re-emergence of this horseshoe shape of cold just here. This is something that we had through 2018. It's faded through this year, but it does look as though this horseshoe shape of cold is beginning to re-emerge now in the Northern Atlantic. So around here it's beginning to cool down, also around here it's beginning to cool down. You see how it's beginning to form that kind of horseshoe shape of cold. That's a signature for a cold PDO, so cold AMO I should say, Atlantic Multi-Decade Oscillation. So it does look as though the North Atlantic is becoming colder, and we are losing those warmer than average sea surface temperature anomalies to the south of Greenland. So I'm not sure the Atlantic is actually terribly well set up for a negative NAO this winter, interestingly. So again, that's last week, and see how things looked last week. This is this week, and see there's been a definite cooling of those sea surface temperature anomalies. Let's have a look at the past year's worth of sea surface temperature anomalies in the North Atlantic. So I want you to ignore the Pacific if you can. Well, you can have a sneaky look at the Pacific if you want, but there's a Pacific there. Ignore that area. I want to focus on the North Atlantic for this final 13th winter update. So we're looking at that area there. That's how things looked in 2018 in comparison to this year. So things are still warmer this year with sea surface temperature anomalies compared to this point in 2018. But you can see, again, we have this sort of horseshoe shape of cold just here in 2018. See that definite sort of horseshoe shape of cold there. Let's run through then. So that's 2017. The Atlantic is warmer at this point in 2017 than it is this year. That is 2016. So generally, the Atlantic is a little bit warmer than this year in 2016, I think. But perhaps not all that much in it. That's 2015, so what do you think about that? Probably warmer this year compared to 2015, actually. That's 2014 again. I suspect the sea surface temperature anomalies are warmer this year compared to 2014. That's 2012, so I think the sea surface temperature anomalies are warmer in 2012 than this year, and where we have got it cooler, it's actually around here, over towards the eastern side of America. That's where you want it if you want a negative NAO. Then this is November, so that was 2013 actually, this is 2012. So again, we see that at this point in 2012, we actually have a bit of a tripole signature. We've got warmer conditions there, cooler conditions there, and then it's warmer down here in the tropical Atlantic. So we do see a tripole already in November 2012. Obviously, we don't have that this year. Let's have a look at 2011. I think the Atlantic is warmer this year compared to 2011. Generally, the warmer the Atlantic, the better it is, better chance, I suppose, of getting some colder negative NEO type conditions. That's 2010. Again, you see much warmer in the Atlantic in 2010, but it's colder towards the east coast of America. So where it is colder, it is conducive towards getting a negative NEO. That's 2009, beginning to see things getting cold around Newfoundland. It's warmer just here, and it's relatively warm through the tropical Atlantic as well. That's 2008, very warm Atlantic to south of Greenland at this point in 2008. That's 2007. So very warm again to south of Greenland in 2007, but the tropical Atlantic was actually a little bit cooler than it is this year, 2007. That's 2006. I think overall a little bit warmer than this year in 2006. That's 2005. So I think the Atlantic again is warmer than this year in 2005, especially sort of around the UK. That's 2004, generally quite a warm Atlantic in 2004, cold over here towards the eastern coast of America. That's 2003. Again, I think the Atlantic is warmer in 2003 compared to this year. That's 2002. So probably a little bit colder with the Atlantic in 2002 compared to this year. That's 2001. Notice as we're going further along, the resolution is getting a little bit more basic as we're going further back in time. So that's 2001. I think overall the Atlantic is a little bit warmer in 2001 compared to this year. That's 2000. We're over here now with the Atlantic. In 2000 we actually have this sort of horseshoe shape of cold, interestingly, and warmer just there. And we still got a relatively cool winter for 2000, 2001. That's 1999 and 1998. 1997 looks like that. Should have been a cold winter. Look at that. I've got a tripole. This point in 1997. It's warmer there. It's colder here. I mean, it's warmer down here. We have a tripole in the Atlantic. But look what's happening in the ENSO region. We've got the Super Nino. That overrode everything. And so instead of getting a cold winter for 97, 98, we actually came away with a mild winter. We're going further back. So that's 1996 compared to this year. So overall, the Atlantic is cooler in 1996 compared to this year. That's 1995, tripole, of course, it's warmer there, it's colder just there, and then it's warmer down here. That's November 1995 before the cold winter, 95, 96. 1994, relatively cool Atlantic, cooler than it is this year. That's 1993, 1992, 1991. All of those years are affected by Pinatubo, so have a very cold Atlantic sea surface temperature. That's 1990. I think warmer in 1990 compared to this year. That's 1989. Quite cold to south of Greenland. Otherwise, the rest of the Atlantic is quite warm. 1998, relatively cold in November 1998 in the Atlantic. 1987. Probably quite closely matched, actually, to this year in terms of the sea surface temperature anomalies in the Atlantic in 1997. 1986, I should say, has a cold and average sea surface temperature anomaly in the northern Atlantic, close to average elsewhere. 1985, generally quite cold with the sea surface temperature anomalies there. We're going into a cold AMO period, of course. Look at 1984, how much colder it is there. That precedes the cold winter of 84, 85 as well, of course. So a colder than average sea surface temperature anomaly in the Atlantic does not mean that we can't get a colder than average winter. That's 1983, and then as far back as we can go is November 1982. These are all cold AMO years, and you can see how much colder it is in the Atlantic then, but it doesn't rule out the chance of getting a cold winter. So anyway, that's the that's how the Atlantic is going to be to start this winter anyway, and I'm not sure it's tremendously good news for a colder winter for Northern Europe with this horseshoe shape of cold appearing in the North Atlantic. But as we've already established, some of those years going further back, particularly the ones into the 80s, like 1986, had a cold North Atlantic, and we were still able to come away with a cold winter. Coming back to ENSO, this is how the SOI is looking at the moment. It's dropping again. So the Southern Oscillation Index is measuring the temperature. It's measuring, I should say, the atmospheric pressures between Darwin and Tahiti down there in the Southern Ocean. When the SOI is in its negative phase, the atmosphere is reflective of El Nino. When the SOI is in its positive phase, the atmosphere is reflective of La Nina. So we've had some quite strong negativity of the SOI in the past week. We can see it from the 18th, 19th of November. We go down to minus 27 on both days with the SOI. 20th of November goes down to minus 19. 21st of November goes down to minus 11. These are very negative numbers, telling us that the atmospheric state over the past few days has been reflective of El Nino. That's come up a little bit over the past couple of days to minus 2 and minus 4 on the 22nd and 23rd of November. You can see from the red line just here that is dropping again. This is the 30-day average for the SOI. You can see that it started up there back in the end of October, but that's where it is right now. It is lowering. If that was to continue, we would possibly go into a weak El Nino through this winter. But despite that, I'm still thinking this is going to be an ENSO neutral winter. I'm not expecting any changes there. 2019 Atlantic hurricane season is drawing to a close. It's winding down. That doesn't mean that it's over. So it's quite interesting. This is a Wikipedia page for the 2019 hurricane season. And actually, they're saying the 2019 Atlantic hurricane season is currently tied with 1969 as the fourth most active hurricane season on record, with 18 named storms and 20 tropical cyclones, although many of those cyclones were weak and short-lived. These are the scores on the doors for the final time for these winter updates. A total of 20 depressions and 18 tropical storms, 6 hurricanes, and 3 major Category 3 or above hurricanes. The number for hurricanes and major hurricanes unchanged. The numbers for total depressions and storms up 1 since last week, thanks to the very late season tropical storm Sebastian. As I say, it has been an active hurricane season, they say, but it's been the 4th consecutive year of above average and damaging hurricane seasons dating back to 1996. The season officially began on the 1st of June and will end on the 30th of November. So, been a very active hurricane season, not hyperactive, I don't think, despite the fact that it's tied with 1969 as the 4th most active hurricane season on record. I think when you measure it all out, particularly in terms of ACE, accumulated cyclone energy, this is above average but not hyperactive, I believe. But that, of course, is subject to change. We discussed in an earlier update what having an above-average hurricane season could mean for the winter. This is how things are looking on the solar disk on our side of this today from solarham.net. So we have a spotless solar disk. Solar activity is therefore at very low levels, have no sunspots at all, and we're expecting solar activity to remain at very low levels over the next 3 days. That's what Solarham is reporting. This is the GWV's 13th winter update solar activity tracker, updated by good friend James Ackrell to the 24th of November. And again, for the final time for these winter updates, you can see from the red line and the green line how solar activity is flatlining away. We're at a very, very weak level of solar activity at the moment. The orange line indicates each individual day's worth of sunspots. So we do have the odd day coming and going where we've got sunspots, but they are outnumbered by the days that don't have sunspots. And so this tells us that we are in true solar minimum. We started true solar minimum back into May. We're not expecting any changes. We're expecting to remain at solar minimum with this winter. So this is going to be a solar minimum winter, we believe. We discussed again in an earlier update, I think it's update number 9, what solar minimum could mean for our winters. It does increase the chance of a colder winter, but it doesn't guarantee. It doesn't guarantee we'll have a colder winter. But I think this has been very, very compelling, hasn't it? The way these coloured lines have just been flatlining away throughout this season of winter updates. This is very much the solar minimum winter of solar cycle number 24. A big thank you to James for keeping the solar activity tracker updated for us through these winter updates. This from our good friend Richard Trott. This is showing spotless days by year, and the current spotless stretch is up to 11 days now. But for 2019, we've had a total of 247 days without any sunspots. That is 75% of the year, which is quite unusual. And this tells us that the solar minimum for solar cycle 24 is a very, very deep solar minimum indeed. To go to 75%, 3/4 of the calendar year, to have no sunspots, that's very unusual, and it is true sort of deep solar minimum. We didn't go quite to that level even in the last solar minimum. Look at 2008, that's when we had the solar minimum year, solar cycle 23, and that had 73% of the year spotless. So we're actually a little bit deeper with the solar minimum for solar cycle 24, seemingly, compared to solar cycle 23, the last solar cycle. So this is a really, really deep solar minimum, and it could be a very long solar minimum as well. As we go into solar cycle 25, we're expecting next winter, winter 2021, to be the first winter of solar cycle 25, but I would expect very weak solar activity still for that winter too. This could be another prolonged solar minimum. It could take a long time to start to come out of this solar minimum, as it did, of course, at the beginning of solar cycle 24. We have 2009 there, having 71% of the year also without sunspots. Very, very slow move out of solar minimum for the last solar cycle. That could well happen again as we go from solar cycle 24, solar cycle 25. Last thing to look at for this first section of the video is Eurasian and Scandinavian snow cover. That's how things were looking across Eurasia and Scandinavia with snow cover last week. This is the latest. So very little change across Western Russia. This is quite unusual now, actually, to have the snow line this far back on the 22nd of November. So the far west of Russia is snow-free. Most of Europe, away from mountainous areas, also snow-free, except over Scandinavia, where we actually still have quite a lot of snow cover away from southern parts of Scandinavia. Again, that's last week, that's this week. So, yeah, you can see that quite clearly this western part of Russia is lagging, but we're still doing quite well across Scandinavia. So let's have a look at this point in 2018. So you see, at this point in 2018, most of Western Russia was snow-covered, as was Eastern Europe. However, Scandinavia was had a lot less snow at this point last year. That is 2017. So most of Scandinavia was covered with snow at this point in Scandinavia. At this point in 2017, actually more snow cover at this point in 2017. Scandinavia compared to now, and the snow line was into western parts of Russia as well. That's 2016. Whole of Russia is covered with snow, very similar for Scandinavian snow cover. That's 2015. Again, the snow line is further towards western Russia and covering most of Scandinavia. That's 2014. Snow line was pushed quite a long way back, actually, at this point in 2014. We had less over Scandinavia as well. So we're doing better for both Russian and Scandinavian snow cover at this point in 2014. That's 2013. So very similar for western parts of Russia, and probably a little bit less, actually, for Scandinavia at this point in 2013. That's 2012. So again, quite similar for Western Russian snow cover, and I think we have more snow cover now across Scandinavia than at this point in 2012. That's 2011, so a lot more snow cover now compared to 2011, but less western parts of Russia. That's 2010. Whole of Scandinavia is covered at this point in 2010, and the snow line is more or less to west of Russia as well. That's 2009. Again, probably a little bit more snow cover now across Scandinavia compared to this point in 2009. That's 2008. The snow line had pushed right the way through into Western Europe. It had surged into Germany and even into parts of France at this point in 2008. Probably got more snow cover across Scandinavia than now, though. They have 2007, so again, we're lagging behind 2007 for snow cover. That's 2006. We're behind, I think, for Russian snow cover, definitely. We're ahead, though, for Scandinavian snow cover. That's 2005. Again, surge of snow into many parts of Europe by late November 2005. We're lagging behind 2005 for Eurasian snow cover, but we probably have more this year across Scandinavia, definitely do. 2004 looking like that, lagging behind again for much of Eastern Europe this point in 2004, but we are ahead for Scandinavia. Scandinavia's had a very, very good snow cover season, I have to say, away from the far south. That's 2003, so behind 2003. We're behind most of these years, you'll have gathered, for Russian snow cover anyway, but we're doing pretty well for Scandinavian snow cover. That's 2002. That's 2001. Again, lagging behind 2001, particularly for Russian snow cover. That's 2000, probably quite close for 2000, actually, for Russian snow cover. Ahead for Scandinavian snow cover. 1999, look at that. The snow had surged even towards southern parts of France at this point in 1999. Quite extraordinary, that. Then the last year is 1998. We're behind again for Russian Eastern European snow cover, but probably quite closely matched for Scandinavian snow cover. And that rounds up part 1 of this 13th Winter 2019-2020 update. The rest of this update is going to be focusing on analogues. It's going to be an analogue special. We're going to go absolutely crazy with the analogues for the rest of the video. So go and get yourself a cup of tea and a little couple of nibbles, perhaps. And we'll meet back here in 2 seconds' time, and then we will go through the rest of the 13th and final Winter 2019-2020 update. I'll see you soon. Okay, we're back. And we're ready to resume the 13th Winter 2019-2020 update from GWV. So in the first part of the video, we was talking about the methodology. So we was talking about things like sea surface temperature, anomalies, solar activity, Eurasian snow cover, all of that kind of thing. We're done with that now for this season of winter updates. We won't be looking at that again. Now until we're going to bring back the Sunday roundup in the new year, so we'll start looking at things like solar activity and sea surface temperature in the Sunday roundup, and of course it will form a big part of next year's winter update. But the rest of this 13th and final winter update are going to be focusing on analogues. It's going to be a true analogue special. We've got more analogues than we have ever had before in a single update, so sit back, relax. We're going to go through these as quickly as we can. So the first set of analogues that we're going to look at is going to be focusing on November data. So, of course, I'm doing the video on the 23rd of November. You're going to be watching this on the 24th of November. And the problem with that we've got is that we are well short of the end of the month. So everything you're going to see here related to November is kind of like a projection. It's where we think the most likely ending point is going to be for this November. Fortunately, it's been a clear signal for this November. A very wet month and a rather cool month. So that makes it easier when we come to do these than it is in a lot of years where things are quite difficult to ascertain where they're going to finish up before the end of the month. This year it's been quite a clear signal for this November, so that does make it a little bit easier. But we're going to start off by talking about the central England temperature. So at the moment, this is the CET from Hadley for November 2019. We're currently standing at around 6.2, an anomaly of 0.8 of a degree below average. That's provisional to the 22nd of November. We're expecting this to tick up a little bit over the next 2 or 3 days and then probably drop a little bit towards the end of the month. There will probably be a downwards correction as well. I've been chatting with my good friend Simon, aka Global Warming, on the Weather Outlook forum. We're having a few little chats and trying to work out where the most likely landing point for this November is. We think it's going to be 6.0 to 6.5. Somewhere in that area, and probably a central projection of around 6.3. Remember, this is just a projection, though, so it may be a little bit up from that. It could even be a little bit down. Wouldn't totally rule out the chance of coming out at 5.9 even for this November. But I think it's going to be low sixes. So 6.2, 6.3, not all that far from where we are at the moment, actually. So the first set of analogues we're going to look at is winters following November with a central temperature of 6.0 to 6.5, somewhere within that sort of landing zone that we think we're going to be in by the end of the month. So the first winter is 1872-1873. This is a very wet winter with low pressure over the top of the country, a deep trough of low pressure. It's not particularly cold, I don't think, but it does look like it's a very, very unsettled and wet winter. The next winter, following a November CT of 6.0 to 6.5, is 1875-1876. This one with a weak area of above average heights to the north and some below average heights down to the south. Winds could be a little bit easterly with that winter. It's probably a drier, quieter and rather chilly winter. The next winter is 1892-1893, again following November CT of 6.0 to 6.5. This one is quite a coldish looking winter with above average heights out to the northwest and below average heights to our southeast. That looks like it could be quite a cold winter for 1893. The next one is 1902-1903. This one is a mild winter with above average heights to our southwest, below average heights to our northwest. We bring in west or southwesterly winds. That's a mild and probably not overly wet winter either for 1902-1903. Next up, we have 1907-1908, again following a November CT of 6.0 to 6.5. This one with above average heights out to our west, below average heights to our east. It's not a bit in between. It's neither one thing or another. I think it's a relatively mild winter, though, for 1908 until the spring, when there's a late snowstorm at the end of April 1908. 1911-1912 shows up next. This one, very unsettled winter. It's a very wet winter and also quite a mild winter as well, very Atlantic driven for 1911-1912. 1912-1913 shows up next, following a November CT of 6.0 to 6.5. This one with lots of low pressure out to the west, high pressure is to the east. This is a mild and unsettled winter, again bringing in low pressure from off the Atlantic, but also southwesterly winds. Then we have 1927-1928. This looks like it's a very mild and wet winter. In fact, most of it was, but the high pressure over towards Scandinavia does give the game away a little bit, because actually December 1927 is very cold. It has a classic white Christmas, particularly across much of England and Wales. Very, very heavy snow over Christmas of 1927, and December 1927 is a cold month, but then when it falls in the new year of 1928, I don't think it really gets cold again, actually. The rest of the winter was quite mild and wet. Then we have 1930-1931, following a November CT of 6.0 to 6.5. This one with a trough of low pressure across the west of Europe and a ridge out to our west. This one looks like a rather cool and unsettled winter for 1930-1931. 1934-1935 comes up next with low pressure sitting to our east and southeast. High pressure is out to the northwest. This looks like it should be quite a cold winter, but I don't think it was particularly. It was a rather unsettled winter, though. 1943-1944 shows up next. This is a milder and drier type winter with high pressure sitting over just to the west of the country. That's a relatively dry and mild winter for 1943-1944. 1944-1945 is our next winter, following a November CT of 6.0 to 6.5. This one with above average heights out to our west and below average heights to the east. There is some cooler weather on offer with this winter. Overall, though, it's not a particularly cold winter. The next one is 1956-1957. This one with some above average heights to the east, but for us, the main driver is actually going to be the low pressure that we have out in the Atlantic. We have this deep trough of low pressure in the Atlantic driving in mild westerly winds and bouts of rain too. That winter, though, does contain another white Christmas in 1956. Quite a cold Christmas then. 1957, 1958 is our next winter, following a November CT of 6.0 to 6.5. This was a rather colder winter. Below average heights are centred to our east. Above average heights are out to our west. And we start to bring in some colder winds from the north. It starts mild with this winter. December 1957 is mild. It gets colder as it goes on, culminating in quite a cold February and March, I think, in 1958. Then we've got 1959, winter of 1958-59 is a rather dry and chilly winter. Not especially cold, but it is a rather chilly winter and quite a lot of dry weather too. 1961-1962 is, of course, overshadowed by the daddy of cold winter, 62-63. But this one does have some cold weather in it. I mean, we've got the above average heights out to our northwest around Greenland and North Atlantic, trough through Scandinavia, and the winds are in from the north quite a lot through this winter. Rather stormy, and it gets cold right at the very end of February. Has quite a cold Christmas around 1961, by the way. Gets stormy then and milder through January into early February. It gets cold late February with a very cold March. This is our first true cold winter, I think, within this particular analogues package. So this is 68-69, following a November CT of 6.0, 6.5. This one has lots of high pressure up to the north, has low pressure to the south. We bring in the winds from the east. It has, again, a white Christmas in 1968, a very wet and mild January, and then it goes really cold for February. February 1969 is a very cold and wintry month. 1971-1972 next. This is a rather dry and quiet winter. Low pressure out to west, high pressure to the east. Very little in the way of cold weather in that one. It's mostly dry. 1972-1973 is also another quiet and pretty dry winter. Lots of low pressure up to the north, but we're close to ridge of high pressure. Not a great deal going on for that one. 1973-1974 shows up next. We have a run of these November CTs between 6.0 and 6.5 through the early 1970s. This one is a much wetter winter. 73-74 is a much wetter winter with low pressure dominating. It's also a very mild winter. 76-77 has a strong northern blocking signal, and low pressure is underneath it. It's an unsettled winter, has a cold December, again a cold Christmas. That could be a trend actually within these November CTs between 6.0 and 6.5. A trend, I think, is there. More cold Christmases than you probably expected a normal analogues package anyway. So it's another cold Christmas, some snow around Christmas 1976, a cold December into early January, then the rest of the winter is mild. Quite a big gap to 1987-1988, which is a wet and mild winter as we bring in the winds from the Atlantic. We've got 1989-1990, which is another very mild and wet winter. There's a trilogy of really mild winters in the late 1980s, starting with 87-88 and finishing with 89-90. So that's another very mild and wet winter. Then we've got 98-99, following November CT of 6.0, 6.5. This with low pressure up to our north, high pressure out to southwest. It's another mild 1990s winter, although there are some colder snaps in it. 2005-2006 looks like it should be a cold winter. Actually, it looks like it should have a lot of easterly winds. It's one of those winds that just never quite comes together, even though the reanalysis looks really good for it to be a cold winter. It isn't particularly It does get cold though late on in February 2006 and through to March, and then the final winter following November CET of 6.0 6.5 is the deluge winter. It's the deluge winter of 2013-2014. Ominous to see this turning up within our analogues package. The Atlantic's unleashed. It didn't stop raining from beginning to end. Every time you stepped out the back door it poured with rain. It was a horrible winter, but it was also a very, very mild winter. Putting all of that together then, this is how all December's combined look following a November CET of 6.2 to 6.5, and it's clearly an unsettled signal for December. Low pressure is dominating the Atlantic and most of Western Europe. It does have some blocking up to the north, as we've explained. There's a fair number of cold Christmases actually within this analogues package, but overall this is a very, very wet signal for December and possibly a colder signal towards Christmas. All January's combined looks like that. Again, very unsettled, low pressure over the UK, Western Europe. The northern blocking signal is strengthening though, some degree to the north in January, so the chance is increasing of colder weather in January. However, overall it looks rather wet and mild. This is how all February's combined look following a November CET of 6.2 to 6.5. Unsettled again, low pressure very close to the country, above average heights tending to be out to our west. Could be a little bit colder with those Februaries, as we would pull the air in from the north with the position of that trough of low pressure. And then all Marches combined look like that, above average heights to our north, below average heights to our southwest, settling down, turning drier in the Marches. And there's probably an equal chance of bringing in either cold easterly winds with that, or drawing up milder southwesterly winds. And then finally, for this analogues package, this is how all winters combined are looking. We have a November CET of 6.2 to 6.5. By the way, for the all years combined charts, we actually narrow it down to 6.2 to 6.5. We have to do that because you can only have 20. Have 20 examples, if you like. Put together. So the all years combined are 6.2 to 6.5 as opposed to being 6.0, 6.5. Shouldn't make all that much difference. So all winters combined look like that. We tend to have below average heights across the west of Europe. We do have a blocking signal, and it's particularly evident, I think, in December and January. But overall, those winters look mild and wet when we have the CET in November between 6.2 and 6.5, or either 6.0 and 6.5. As I say, taking out those ones at 6.0 and 6.1 should make a great deal of difference overall. Right, that's it for the first package of analogues, but we've got more to come. The next set of analogues is going to look at November rainfall. We've had a very wet November. We think we're going to be somewhere within the top 25 or top 20 wettest Novembers. We'll see what the winters were like that followed the top 20 to 25 wettest Novembers very shortly. I'm going to pause the video there, and we'll meet back again in around 2 seconds time, so see you very soon. Okay, we're back, and we're ready to resume the 13th and final winter 2019-2020 update. What have you thought to it so far? I hope you've been enjoying it. Please let us know in the comments what you're thinking about this winter update. And don't forget to give us a like as well on the video to let us know that you have enjoyed it. Right, so before the break, we was talking about the November centering temperature, looking at winters following a November CET of 6.0 to 6.5. That's where we think we're going to finish up with this November CET. We can't be absolutely certain, though. And again, we can't be absolutely certain on precipitation either, on rainfall either, but it has been a very wet November. We think we're probably going to be somewhere within the top 25 or top 20 wettest Novembers. That's what we've been looking at, the winters following the top 20 wettest Novembers. That's what we're going to look at for this next batch of analogues, but we won't be done there. We'll have even more after this set of analogues. We've looked at the top 25. We've actually got 21 years with this because we're looking at England and Wales precipitation. The England and Wales precipitation goes back into the 1700s. And of course, for reanalysis, we can only go back to 1836, I think. So we can't go back in 1700, so that means that's one or two of these years are taken out. So we have looked at top 25 wettest Novembers, but we've actually only got 21. And that's the reason why. Anyway, let's get on. So we're going to begin. These are not in order, by the way. These are just in annual order, by the way. We're not in sort of number 25, number 24, number 23, number 22 to number 1. Not for this batch of analogues. We may have something a little bit later on, but is in order. But the first, so these are in a chronological order, if you like. So the first top 25 wettest November is 1836, November 1836. This is the winter of 1836-1837, and it has a blocking signal. It has high pressure up to the north with low pressure to our south-southeast. You can see we will be pulling in cold winds from the northeast. That's a cold winter for 1836-1837. Next up, we have within the top 25 wettest Novembers, November 1852, and this is the wettest November of all, by the way. This is wettest November on record. Hasn't been beat. I don't think November 2019 is going to beat this either. But the wettest November on record for England-Wales precipitation is 1852. The winter of 1852-1853 looks like it continues the deluge, actually. Must have been an awfully wet period because there's a trough of low pressure over the UK and much of northern Western Europe as well. Northern blocking is there. I don't know if it's a particularly cold winter, but it does look like it's a very, very wet winter. The next top 25 wettest November is 1875. The winter of 1875-1876 showed up in our earlier analogues package, I think. Looks like that. Above average heights just to our north. It's a rather drier and quieter and potentially quite chilly winter. Next we have 1888-1889. This is quite a cold winter with above average heights just to our west and below average heights to our south. You can envisage we're pulling in fairly chilly winds during this winter. It does have some cold weather in 1888, 1889. A long gap then to 1926. November 1926 is a top 25 wettest November. This is how winter of 1926-1927 looks. Looks a rather anticyclonic winter, actually, with a fair amount of high pressure close to the UK. So I think it's a relatively mild and relatively dry winter in 1926-1927. Next, we've got 1929-1930. Very, very wet winter. This one, low pressure in from off the Atlantic. That's a really wet winter, following a top 25 wettest November as well. Then we've got 1935-1936. This one is another very wet winter. 1935-1936. Not particularly cold, even though it does have a bit of a northern blocking signal. That's another very wet winter. So there's perhaps a bit of a trend here, actually, for wet Novembers to be followed by wet winters. But then we've got 1939-1940, and this one sends the jet stream southwards, and it builds up high pressure to our north. So November 1939 is a top 25 wettest November, and it's followed by a severely cold winter for 1939-1940. As I've explained, there's a long gap between 1895 and 1940 where we didn't have many severe winters, but that ends that gap. Next up, we've got 1940, 1941. This is another cold winter. There's a trilogy of very cold winters in the early 1940s. This is another one of them. Again, following a top 25 wettest November. Then we have 1944, 1945. This one has the above average heights just out to our west, and it has below average heights to the east. Again, it's not a particularly cold winter, but it does have a few cold snaps. We've got a daddy cold winter showing up, 46, 47. Look at this, below average heights to the south and strong northern blocking up to the north. This is a very, very severe winter. Starts late, in late January 1947, but when it gets going, my word, does it get going. It's exceptionally severe winter. Loads and loads of snow. We're snowbound from late January to the middle of March. And it is here with a top 25 wettest November. 1950, 1951 looks like that. It's an unsettled winter, low pressure across the UK, Western Europe. Has a cold December in 1950. The rest of the winter is mild. 1951, 1952 has above average heights to our west, below average heights to our east. That's the rather cold and unsettled winter. Then we have 1954, 1955, another cold winter. This looks like it's a trend, doesn't it, of cold winters following wet Novembers. Yes, we have the below average heights over and to the east of the country, above average heights blocking towards Greenland. That opens the door to the northeasterly winds. That's a cold winter for 1954, 1955. 1960, 1961 is one of the milder winters of the 1960s. So although there is a bit of a trend towards colder winters following wet Novembers, it's not every winter by any means. That one is a mild and wet winter for 1960, 1961. 1970, 1971 has above average heights to the north, below average heights to the south. We bring in the winds from the east, although it's generally quite a mild winter, except it is a little bit colder in December, has a white Christmas. 1984, 1985 is another cold winter. There's definitely a trend here within this wet November analogues package for a colder winter. Below average heights to the south, blocking to the north. Yes, we've got the wind in from the east. That's a cold winter for 84, 85. 92, 93 is a dry, quiet and mild 1990s winter with high pressure over the top of the country. 2000, 2001, following again a top 25 wettest November. This one with low pressure to our south, but quite strong blocking to the north. That's a cold signal. That's a cold winter for Scotland. A little bit on off though, and for England and Wales, not a particularly cold winter. 2002, 2003 looks like it should be a cold winter. It was, and again, it's another one of those winters that never quite comes together. And then finally, for these wet Novembers, top 25 wettest Novembers, we've got 2009, 2010, following the deluge November 2009. This, again, is a cold winter. Low pressure is down to our south. High pressure blocking to the north. We're pulling in cold winds from the east and from the northeast. That's a very cold winter for 2009, 2010. Putting all of that together, this is how all Decembers combined are looking following the top 20 to 25 wettest Novembers. So for December, it's a wet, unsettled signal for much of Western Europe, but it does have a strong blocking signal up to our northeast. So you can imagine that several of those Decembers are going to be threatening cold weather. January, look at January, strong northern blocking towards Greenland when we combine these Januaries following the top 25 wettest, or top 21 wettest November. So for January, yes, a cold signal here. You can envisage a jet stream on average would be going to the south of the country. All February's combined strengthens the blocking signal even further. So very, very strong northern blocking towards Greenland. Low pressure to the south, favouring bringing in those easterly winds in February. Goes on into March. March is also favoured to be a cold and wintry month with northern blocking following the top 25 wettest Novembers. And then finally, putting all of the winters together, this is how all winters combined are looking following the top 25 wettest Novembers. Yes, northern blocking is there. Below average heights over and to the south of the country, favouring bringing in the winds from the east or from the northeast. Definitely a wet November is favouring a cold winter. We can definitely say that quite clearly within that package of analogues, that there is an much greater than average chance of those winters being cold following a very wet November. As I say, we don't know for sure that this November will be a top 25 wettest November. We think it probably will. We won't know for some time. But if it is, then that increases the chance of a colder winter quite clearly. Right, we are not done there. I probably thought that was going to be the end, but it's not. We're going to pause the video one final time, and then we're going to be back looking at some more analogs. This time we're going to look at winters following the top 20 wettest autumns. Yes, we're going to look at some autumn data, so I'll see you very, very shortly for the final part of the 13th and final Winter 2019-2020 update. See you in 2 seconds' time. Okay, we're back and we are ready to resume the final part of the 13th and final Winter 2019-2020 update. It's been an analogues special and we are not done yet. We've got one final batch of analogues to show you. We're going to go through the top 25 wettest autumns and show you what the winters were like that followed then. We're very confident that autumn 29 will be within the top 25 wettest autumns for England and Wales precipitation, and we're going to show you in a moment what winters were like that followed those wet autumns. I hope you've enjoyed this winter update. I hope you enjoyed this season of winter updates as well. And if you have, then please let us know in the comments that you've enjoyed this video, and of course don't forget to give us a like. So as I say, we know that this has been a very wet autumn for England and Wales so far. So for September and October, this is how things look in terms of the percentage of average. So we see widely across England and Wales with those blue colours showing that in September and October there were a pair of wet months. We're adding November to that, so we're really confident that autumn 2019 will be in the top sort of 25 wettest autumns on record. So for the final time for this video, our final batch of analogues is going to look at winters following the top 25 wettest autumns. So, and these are in numerical order as well, by the way. So at number 25 we have the autumn of 1929. There will be crossover, by the way, with some of these wet autumns with the wet Novembers. So at number 25, we have the autumn of 1929, and it's the winter of 1929-1930, and that's wrong up there in the browser. I put that in wrong, so I think better get rid of that. And we're going to have a look at winter of 1929-1930. It's a very, very wet winter, as we established with the November analogues. Yes, it's a wet and mild winter for 1929-1930. At number 24, it's the autumn of 1998. The winter of 1998-1999 has low pressure up to the north, high pressure out to west-southwest. We bring in those westerly winds. It's a mild 1990s winter. Many of them were in the 1990s. Does have a few cold snaps. At number 23, we've got the autumn of 1967. The winter of 1967-1968 is quite cold, with high pressure to our west, low pressure to our east. There's regular cold snaps through this winter, especially in January and February. Then we've got the winter of 1940-1941, showed up in our earlier analogues package for the wet Novembers. This one is another cold winter, of course, the trilogy of cold winters in the early 1940s, with blocking up towards Greenland in 1940-1941. Number 21, we've got 1883. The winter of 1883-1884 looks like that. High pressure is giving us a drier type winter and also a relatively mild winter. At number 20, it's 2012, and the winter of 2012-2013 has low pressure to our east and blocking up to the north. It favours bringing in east to northeasterly winds. It's a winter that gets colder and colder as it goes along, culminating in a severely cold March. Number 19 is 1839. The winter of 1839-1840 looks very unsettled, with low pressure to our south. High pressure is blocking up to the north. But I think the main thing with that winter is that it would be very wet. Then we have 2002-2003 with, of course, the autumn of 2002 at number 18. This one, again, looks like it should be a cold winter. It isn't, though. It's one of those winters that doesn't quite come together. Next up, we have at number 17, the autumn of 1836, and then the winter of 1836-1837 looks like it would be quite cold, with below average heights to the east and blocking out to the northwest. At number 16, we have 1882, the autumn of 1882, followed by the winter of 1882-1883, which is a mild winter and also an unsettled winter too. Number 15, we have 1984. Yes, that's right, 1984, with the winter of 1984-1985 being a cold winter. It showed up in our November rainfall analogues, of course. Here it is again with the autumn analogues. It's a cold winter for 84-85. At number 14, it's 1885, with the winter of 1885-1886 looking like this. Low pressure to the south, high pressure is out to the northwest. That's a rather colder winter. Number 13 is 1944, the winter of 1944-1945. Again, showed up quite a lot with these analogues. Low pressure to the east, high pressure to the west. There is some cold snaps. It's not a particularly cold winter. At number 12, we've got 1974-1975. This is a mild and dry winter with low pressure up to the north, high pressure to our south. Number 11 is 1954. The winter of 1954-1955 is cold with low pressure over to the east of the country, blocking out to the northwest. Relatively mild in December of 1954, then gets cold for January and February. We're into the top 10. At number 10, in terms of the wettest autumns on record, we have, for England and Wales, we have 1880. The winter of 1880-1881 is a cold winter with low pressure to our south, high pressure towards Greenland. Jet streams down here. Has a severely cold January in 1881. Number 9 is 1841. And this one, quite a cold winter. High pressure is up to the north. Low pressure is to the south. That looks like it's quite a cold winter. Then we have 1903 at number 8. The autumn of 1903 is our 8th wettest autumn on record. The winter of 1903-1904, very wet. Low pressure is through the west of Europe. That's a mild and very wet winter, 1903-1904. Number 7 is number 7. That's wrong again. Let's get rid of that. So, number 7 for the top 25 wettest autumns on record is 1872. And the winter of 1872-1873 is also very unsettled, with low pressure dominating. Number 6 is 1976. The autumn 1976 is the 6th wettest autumn on record. Low pressure in the winter of 1976-77 is over UK. High pressure up to the north. Talked about this earlier on. Has a cold December to early January, then it's milder. Top 5. So the 5th wettest autumn on record. Been a very, very long video, been a very long day. Struggling a little bit now, but we're coming to the end. The at number 5 for the top 25 wettest autumns is 1875. The winter of 1875-1876 is a rather dry, quiet, and possibly quite cool winter. At number 4, we've got 1835. The winter of 1835-1836 is very wet, very unsettled winter and quite mild. Top 3 now. So the 3rd wettest autumn on record is going to be 1960. Again, let me just get rid of that. It's going to be 1960, and the winter of 1960-1961 is very wet and unsettled. It's a relatively mild winter too. Most of the winters in the 60s were cold, but not that one. Then we've got 1852 at number 2. So it's the wettest November on record, and it's the second wettest autumn on record. The winter of 1852-1853 is also unsettled, with low pressure over country. High pressure is blocking up to the north. And then the wettest autumn on record is the autumn of 2000 for England and Wales. Anyway, the wettest autumn on record is the autumn of 2000. Winter 2000-2001 again has high pressure to the north. Low pressure is out to our west. It's a cold winter for Scotland. There's some cold weather at times for the rest of the UK, especially around Christmas, and then on off through February and March. There are some colder interludes. Putting all of those top 25 wettest autumns on record together, this is how Decembers are looking when we combine them. It's an unsettled signal for December with low pressure over the UK, Western Europe. Again, it has that blocking signal though up to the northeast. And then we go through to January. It's very similar to the rainfall, to the November rainfall data. For January, again, we strengthen the blocking towards Greenland, take the low pressure projection further southwards. There's a better chance that January goes cold. The cold signal strengthens for February following the top 25 wettest autumns, with low pressure down to our southwest, high pressure blocking up to the north. A lot of these Februaries are going to be cold with easterly winds. And then into March, yes, the cold signal continues for March, with low pressure and rejection going south down there, blocking up towards Greenland and Iceland. And then finally, in the final analysis, putting the top 25 wettest autumns on record together, this is how all winters combined are looking. It's a cold signal, definitely. High pressure to the north, low pressure to the south, bringing in the easterly winds. You would expect, on average, many of those winters following the top 25 wettest autumns to be cold, and some of them would be severely cold. And then finally, just say that if you've enjoyed this winter update, if you enjoyed this season winter updates, please can consider becoming a patron for GWV. We've got 67 patrons so far, so hello and a big thank you to our 67 patrons. If you'd like to become a patron for GWV, all you need to do is come to the GWV's Patreon page, sign up for a Patreon account, give an ongoing monthly donation to GWV to help us pay for the website and keep content online. We're hoping to get 70 patrons for Christmas, but not sure we're going to be able to do it. Alternatively, there is PayPal, so you can give a donation through the GWV's PayPal page. So you just come here, sign into your PayPal account, and give any donation you like. Whether you do it through Patreon or PayPal, you're going to get a mention in videos. We'll give you a shout out, say thank you so much for doing that. Right, 1 hour 15 minutes to go through 110 tabs. Actually, it's 112 with PayPal and Patreon added. I don't think that's too bad at all, to be honest. And that's it. That brings us to the end. I think this 13th update has really thrown a curveball, because particularly with the November rainfall and the autumn rainfall, I think that's a very, very strong signal there for a cold winter to follow. So quite what we make of this, you're going to find out next week when we release a winter forecast. But I mean, I think this has definitely thrown a little bit of a spanner in the works, and we're just going to have to see what we come out with for the winter forecast. So that is it for your winter updates for this season. I hope you've enjoyed them. There's going to be a live stream on YouTube between 5 and 6 o'clock where we're going to talk about this winter update. So please let me know what you think and whether you enjoyed it. Coming up later on, we're going to have the ECWF Metro France and DWD Season 1 update. We'll have a Christmas update as well. This video will be placed on the winter updates and forecast page with a written summary going over everything that we discussed in the video. I'll get that up for you around 8 o'clock this evening. And then all we've got left to do is on Saturday, the third and final Season 1 roundup. And then Sunday, week today, it's the big one. The winter 2019-2020 forecast will be released at GWV, and you'll see what we're forecasting for this winter then. Okay, I'm going to stop the video there and go and collapse somewhere out back. And I'll see you later on for that live stream on YouTube between 5 and 6 o'clock. Alright, that's all for now though. Thanks for watching.